These are the easiest ones to do.
Sweet.
All you need to do is remember a couple things. You don't need a calculator or anything to figure these out. There's actually three types of special right triangles. One of them is hardly ever used, so we just do the most common ones. In building and architecture, there's two very common right triangles that are used. One like this and one like that. These are special right triangles. This one has a 45 and a 45 and a 90-degree angle. So since two angles are the same, what do you know about the sides? Two sides will be the same. These two sides will be the same. Since these are both 45, it's isosceles, which means these are the same. And then this one, anyone got to guess what the degrees are here?
45.
This is 45, 45.
90, 30, and something else.
30,
60.
60,
90.
90. Okay? To split it up a little bit, we're just going to do the 45s today, and then the next lesson, which won't be till Monday, we'll do the 30, 60, 90s. So, on a 45, 45, 90, there's different ways that they'll draw the triangle for you. Sometimes they'll just put 145 there, and you need to recognize that since this is 45, this one also has to be
45.
Okay? Or sometimes they'll just put in that these two are the same, which means they have to be 45. And sometimes they'll put that the two sides are the same, which means these have to be 45. So this is the three different ways that they would show it, and you need to recognize that it's a special right triangle. Now, if you forget the rules for these, you can still use the Pythagorean theorem on it. Pythagorean theorem still works on both of these. A squared plus b squared equals c squared. But when you get to this one, Pythagorean theorem won't work. You do need to know the rules for that. Now, here's, see if you can figure out the rules. If you knew that this was 6, and they were looking for the hypotenuse, okay? In order to figure it out without knowing the special rules for it, by the way, what they usually do is there's always going to be a couple things they're looking for, x and y. So we know what y is, right? It's 6. Because since they're both 45, the sides are the same. The two legs are always the same. Then we can figure out x using the Pythagorean theorem. 6 squared plus 6 squared equals x squared. So what we got to do is take 36 plus 36, which is 72. So then you square root it. Now the difference on these is these will be in radical form. So remember we just got done simplifying radicals?
Yep.
What perfect square? 9 works. Is there a bigger one? When I get to it, you'll see it.
It's a 9.
36.
Whoa. What?
Okay, square root of 36 times the square root of 2
Oh.
is 72.
That's 71.
And the square root of 36 is 2. Okay? Or I mean, sorry, 6. So x would be 6 square roots of 2. Okay? If it was a drawing like this, say the leg was 8. So then if they're finding x and y, obviously x is 8. And again, you can do the same thing. 8 squared plus 8 squared equals y squared. 64 and 64 is 128. So you got to square root that. I'll go one more. Any idea which perfect square goes into 64? Square root of 64 times 2, which simplifies to 8 square roots of 2. Okay? Then we'll do this one. Let's say the sides are 3. That means x has to be 3. And then we can use the Pythagorean theorem. Anyone see the pattern yet?
Yeah.
3 squared is 9 plus 9, which is 18. And then you got to square root it to figure out y. What perfect square goes into there? 9 times 2, which is 3 squared roots of 2.
3 squared, or 3.
So does anyone see the pattern to find the hypotenuse? Somebody's got to be able to figure it out.
It's always like.
Yeah, the one side, the other side.
Oh, yeah, 6 square roots of 2. 8 square roots of 2. 3 square roots of 2.
Whatever the legs are, the hypotenuse is just the leg times the square root of 2.
Whoa.
So if you had this, if this was 12, this would be 12 and this would be 12 square roots of 2. Okay?
Okay.
So that's the first rule.
I figured that out.
No one cares.
I'll put that over here so you got it for an assignment. Okay, when you're doing these, a right triangle always has, in this case, the legs are the same length, right? And then there's the hypotenuse. The hypotenuse is always equal to whatever the leg is times the square root of 2. That's the first rule. Okay? Then the other rule is if you know the hypotenuse and you're looking for the legs. Okay, so if this was 8, x and y are going to be the same, so you just got to find one of them. Now, since they are the same, you don't need to call it y, you could call it x, right? So again, you could use the Pythagorean theorem. The leg squared plus the leg squared equals the hypotenuse squared. So what's an x squared plus an x squared? X squared times x squared is x to the 4th. You got to add them. If you got an apple and another apple, what do you have? 2 apples.
2 apples.
An x squared plus an x squared is 2x squared equals 64. So then to solve it, you first got to divide by 2. And then you got to square root it. So what perfect square, I should have left them up there, but what perfect square goes into
82.
It's a 32, yep. 16 times 2. So it's 4 square roots of 2.
Oh, it is the answer.
You did not just do that.
Okay? So x is 4 square roots of 2, and so is y. Okay, if this were 10. So, you figured it out already? It would be 5 square roots of 2. If this this was 30
15 square root of two.
and 15 square roots of 2.
Get off me.
Yeah, get excited with
Joy.
math.
Okay, so the second rule then
Give me
is,
$1 again.
this is what you use if you're looking for the hypotenuse. If you're looking for the leg, it's half of the hypotenuse times the square root of 2. Okay? Now, I chose even numbers. You know, these are all even.
Yep.
Sometimes they'll be odd. So if this was 9, what's half of 9?
3.
4.5
Oh,
square roots of 2.
Oh my.
Holy crap.
That is going to be on YouTube. Do you want to get your picture on there?
Me? No, I'm good.
What's gonna be on there? Carter's saying half of 9 is 3.
Hey, follow me on Instagram.
Okay, now, in the book though, you can write it this way. You can, you can write it this way, 4.5 square roots of 2. But in the book, they write it like this, 9 square roots of 2 over 2. Okay? This
I like it.
and this are the exact same thing, right? 9 over 2 is 4.5. So anytime it's an odd number, the book doesn't actually divide it out. They just leave it 11 square roots of 2 over 2. Okay? But, shh, quiet. It won't be wrong if you write it 5.5 square roots of 2. Okay? Because they mean the same thing. This is just 11 over 2 and that's 5.5. They're the same. Now sometimes they throw in if a side is a square root. If this side is a square root, what's this one? Square root of 2. And then remember the rule is the hypotenuse is just the leg, which is square root of 2, times the square root of 2.
So that's
Square root of 4, which is
which is
2.
2.
Yay!
Yeah,
Okay.
Lily.
Then vice versa, sometimes they throw it in. Now these are the easiest, but people don't recognize it. If this was 10 square roots of 2 for the hypotenuse.
Each one's 10.
Joey figured it out. Each one is 10.
Damn.
Because if you do it backwards, the leg times the square root of 2 is the hypotenuse.
Makes sense. That makes
So
sense.
these would have to be 10.
Okay.
Yeah.
Okay? Okay, so all we're doing today is the 45-45s. Next week we'll do the 30-60. So, if the two legs are 7, what's x?
Ow.
49. 7.
7 square roots of 2. The rule's right up there in case you forget.
Let me get our